Thanks for joining us this morning, and thanks to Chase from Edison Motors for joining us today. The idea here is just to have a small group meeting, turn on your cameras, and there's going to be no PowerPoint other than the two slides I have here, but just a discussion about diesel electric hybrids and some of the work that's been done at Edison Motors. I figured what we would do is have each of the OEMs, just one person from each of the OEMs that are on the call, kind of introduce themselves, their product, the challenges their sector faces as they move to zero emissions, and they're interested in diesel electric propulsion technology, where it comes from, and what they're potentially doing that may align with where, Chase was pretty excited about reading some of the stuff in the Globe and Mail about what Edison's been doing, because the duty cycles are very, very similar to ag equipment, and some of the other stuff is built here in Manitoba. After you've done your introductions, Chase is going to introduce us to Edison Motors and some of the things that they've done and where they're headed with their technology. And after that, we'll do a Q&A. And I guess just to kind of keep it clean and easy so that we're not talking over each other, if you have a question, just raise your hand electronically. I'll acknowledge you. You ask the question, we'll get Chase's comments and answers and those sorts of things. And then, we'll just move from question to question. When we run out of questions, I guess we're done. So we'll work on it that way. So what I'm going to do here is I'm going to call out each company that's online. And if one of you could pop on your camera and just give us an introduction give Chase an introduction to your company and where you guys are headed in zero emission propulsion, that would be great. So start with Corey over at Sandvik.
Sure, I'll see if I can get my camera working here. There we go. Is it working? Jesus. There we go. Hi everyone. So Corey Flanagan, the GM over here at Sandvik Mining. We do have two different lines. We have an ITH drilling line for underground drilling. We're currently working on our drilling platform, our chargeable drilling. So that's got a kind of a horizon of 2030. We have still working on some of the battery chemistries and some of the wheel end drive stuff, but on the load and haul side, which is what we currently manufacture in Winnipeg, which you may have heard of before, was Artisan out of California, which is a company that we purchased a couple of years back. And so we have a full battery electric load and haul truck for underground drilling for 50-ton mining applications, and actually up to 65-ton now. So we're manufacturing those. Some of the engineering most of the engineering is housed in Finland and or in Camarillo, but we do all the manufacturing and supply here.
That's great. Thanks. Thanks.
Glad to be here.
Let's move on to Bueller. I don't know if Grant or Aaron want to pop on.
Hi, I'm Grant. Aaron as well is on the line here. I see. We manufacture high horsepower tractors, like basically using 15-liter Cummins engines, right down to 6.7-liter engines. So very large articulated tractors over 600 horsepower and using power shift transmissions. And we are looking very interesting on looking at what you're doing, and I think we're kind of doing the same thing in a different way, but be very interesting to learn from you what lessons you've learned and successes you've had.
That's great. Why don't we move to Les over at ATI?
Hi, this is Les Funk here, ATI. We build, it's Airport Technologies, ATI stands for. But anyway, we build airport snow removal equipment, snowplow truck vehicles, and snow blowers, and also sweepers. We have kind of done some projects just doing feasibility studies on electrification. Haven't really seen much from our customers looking for that, although they are starting to show up in at least one spec we've seen from one of our larger customers. So we're kind of leaning towards the hybrid concept that Chase and Edison Motors is looking at. So we're kind of interested in what kind of components they're using and maybe seeing how that might fit into our vehicles too.
Yeah, you should describe, Les, your big blower with the two motors and.
All right, yeah. So both of our blowers are two engine. We have an engine that runs the chassis and one that runs the snow blower head. Our largest is the 1050. It has a C15 running the chassis, which is about 540 horsepower. And then the 1050 stands for the C27 that we use to run the bank head. It's 1050 horsepower. So we're in the high end, and it's, again, we're probably the most challenging to get to that electrification, getting to those horsepowers. So.
That's great. Thanks, Les.
Yeah. Battery's not going to do that kind of power.
Yeah.
It's not wrong.
All right. Let's move to Elmer's Manufacturing. I don't know if Riel or Chad, you guys want to jump on, give us an introduction to Elmer's.
Yeah, I can do a quick one. So Elmer's Manufacturing, we're in Altona, just an hour south of Winnipeg. We make pull type implements for agricultural applications, mainly grain carts, harrows, and ditchers are our big three. Some applications we're looking into for hybrid or battery type applications is actually on a new product. We're looking at field bins, and so we don't always have a tractor available, or it's not always turned on. So we'd like to be able to remotely operate it, and trying to figure out how we can power that. We looked into solar panels a bit, but it's challenging. So maybe hybrid opportunities will be a good fit for us.
Excellent. Excellent. Thanks so much. Thomas Small from New Flyer. I see you're out there. Can you give us a bit of an introduction for Chase as to New Flyer? I know you guys are fairly well known, but do it anyway.
Yeah. So New Flyer, we move people, transit buses and motor coaches, and we've been on an electrification journey for many years. In the battery electric front, really, we started with a development demonstration project in 2011, but had been building trolleys since the 60s. That's overhead lines, hybrids, dabbled in fuel cells in the late 90s. And really no demonstration projects, were science projects basically. Hybrids started in 2002. They are now tapering off to nothing. We still have one holdout that we're going to finish up, but with engine emissions changing, they fizzle out in 2026. Battery electric buses and coaches, however, and now fuel cell coaches are as part of our repertoire. A long journey, got lots of sales. We actually have over 60% of the RFPs coming in the door are for zero emission buses, less on coaches. That will follow, and we expect coaches to follow truck as to leverage that infrastructure. The key thing, though, in our markets is that for coaches, it's sporadic from the public sector for commuter coaches. Basically, going from New Jersey into Manhattan is one application, and a number of those Facebook employee shuttles and whatnot that can utilize the electrification. Tour and charter, however, will be a long ways off for electrification. They're very low cost, and charging infrastructure is not ubiquitous yet. The other challenge is on the fuel cell front. Lots of centrally fueled applications for public transit will manifest there, and we're seeing lots of sales with that, especially in California. But on the coach front, we're trying to see where that would actually land. Again, infrastructure is key for that. That's overall summary regarding New Flyer electrification front. I'll add, we do have a company called Arbach under our umbrella as well, working on their electrification plan. This is a smaller, airport shuttle type of application. And ADL, which is Alexander Dennis, has cornered the market on the double deck buses and have sales in North America and worldwide.
Awesome. Thanks, Thomas. I see a 204391 number there. I was wondering who that is and if it was PLS or CanAgro, or somebody, if you could give us a bit of an introduction. Oh, I guess not. So yeah, the MacDon guys, if they do join us, MacDon is a huge company that builds combine headers, is their primary product. They also build windrowers, which are diesel propelled, and again, on the path to zero emissions. But in ag, it's a really complicated thing because, as you and I were talking about yesterday, there's not a lot of chance for power regeneration. So any kind of power you generate is going to be used. So it's not like a give and take thing where you're going downhill with logs and you can actually charge your batteries. It's a little different in that world. So hopefully the guys from MacDon can join us. But yeah, Chase, leave it to you. Introduce us to Edison Motors and how you got started and where you guys are headed.
Yeah, my name's Chase Barber. I'm with Edison Motors, and basically we're building hybrid electric semi-trucks out of BC here. We started this company about 2 years ago, so our background is logging, so we've never really been any like kind of electrical engineers. We had a company that we had logging trucks, and we've been hauling logs for about 15 years. And we were kind of looking at logging trucks or electric trucks because it made sense, especially in BC. You're going up the mountain empty, coming downhill loaded. And when we looked at electric trucks, we kind of said, nobody's making an electric truck to do off-highway logging. Like, that's just does not appear to be happening and still has not happened. So we decided we'd start our own company. We called it Edison Motors. And last year, we built our first prototype, kind of a proof of concept for diesel electric, because we went the diesel electric route because when we started doing the math, there was no way that battery was going to work for us. The total power consumption of a logging truck per day is around 2.5 to 3 megawatts of consumption. You would need 3 times, 4 times bigger battery than a Tesla semi. The battery would end up weighing like 50,000-60,000 pounds. But we realized we could just put in a little diesel generator, let the diesel generator recharge the batteries. That would give us the efficiencies of the electric while still being able to, all the efficiencies of the electric while still having the range of the diesel. So about 2-3 months ago, we just unveiled our first production prototype, we're calling it. And now we've done a little sales and we're just starting our first production run. So it's kind of exciting.
Oh, good stuff. Good stuff. Yeah, so you guys you've obviously been up in the bush with it already, your prototype truck. What kind of things are you noticing with it that are expected or maybe unexpected benefits of going electric?
Torque. The torque is fantastic. There's no driveline twisting or anything like that. It's just instant power to the wheels. This thing can move 100,000 pounds like it's bobtailing around. It does not notice the thing. The regenerative braking is a lot stronger than you would find on a normal Jake brake, which makes a big difference in BC if you're logging. So what we found on our testing is that we're getting about a 50% increase in fuel mileage. So we're burning about half the amount of fuel by going hybrid. So it's quite significant. More power, more torque for less fuel. It's, you're looking at a logging truck. You look at a logging truck in BC where it's burning $15,000, $20,000 a month in fuel. 50% of that, not insignificant. You're looking at like an $8,000 a month fuel savings by going hybrid. And what we also found is that electric was relatively easy to work on. And that's where we've been trying to do a lot of education on through social media and all that, trying to show off the electric side of things, is that it's actually pretty simple. With our whole ethos is we built this thing for ease of repair, right to repair, no planned obsolescence. Basically, on the background, we built this thing behind my parents' house in their backyard, like just using the tools we had in a tiny shop for a couple logging trucks and just the parts we could find at a local parts store. We were able to make a working, driving electric truck. And it was one of those things where I was getting so mad at the whole way that the trucking industry is going. The trucks were getting less reliable, less serviceable. Like compared to my old trucks that I've got, we've still got 4 or 5 old trucks from the 60s and 70s, and those things are workhorses. They just go to work every single day. If you got to work on them, they're easy to work on, easy to repair. So when we built the truck, we kind of built it with that old 1960s design in mind. In fact, we copied a lot of parts off of the old, I don't know if you guys know the old Laterno log loaders or Laterno company, but the sawmill in Merritt, to give you an example, runs a bunch of log loaders to unload logging trucks. They've got 3 of them. One was built in 69, 71, and 67. So these pieces of loaders are over 60 years old, which, I mean, is fantastic. They're unloading 200-300 trucks a day. They're getting better fuel economy still than a brand new loader. And they were built so simply, so easy that their little diesel electric drive is still in operation 60 years later. Like it really is easy to build, easy to work on if this diesel electric is done right.
Mm-hmm.
So that's kind of our whole ethos. That's why it was easy for us to build these trucks with the small company we are. And we're hoping that they're going to be easy to service when they get into the customer's hands. So we've kind of just been sharing that whole journey, what we've found, what we've learned. I like to say we're the most transparent EV company. You can see all of our failures on YouTube of the things that didn't work and things we learned from and things we redesigned and re-engineered going forward. So I think that's kind of why I'm here, to hopefully answer some of those questions, mistakes we made or things we've learned, way we did things.
Excellent.
Because I'm imagining the agricultural world isn't going to be friendly. Like there's no way you're going to make a battery electric tractor work. Like buses go back to the same terminal. Buses aren't crazy power intensive. They can put in planned charging places. They can have a controlled thing. Buses normally go back to their terminal. Logging trucks, low bed, tractors don't. Like a farmer isn't going to be able to put a charger in every one of his fields in order to charge his tractor, especially when a tractor is running like a Cummins X15 in a tractor. Buses don't need to run X15s. They're tiny little 7-liter motors.
Mm-hmm.
You can start replacing that size motor. You're never going to replace a 500 Cummins, 600 Cummins.
Yeah. So just for, give us a high level walk through your propulsion system, how you basically got it, which wheels you're driving, just kind of a high level, how you put it together.
Okay. Yeah. So high level view, it's, we like to say it's a fully electric truck. The best way to describe it is that this truck is completely 100% full electric. It's got batteries mounted in the frame rails. It's got electric motors on the back end. And up front, it's got a diesel generator that basically, as the battery gets low, the generator fires up, recharges the battery, allows the truck to keep driving. What we find is you get about 2 hours of driving, and then the generator fires up for about an hour, and then you drive for an hour, shut down too. It, of course, depends what exactly you're doing with the truck, but that's the gist of it. Mm-hmm. So I'd like to say it's a fully electric vehicle that packs around its own fast charger.
Okay. What voltages are you running?
So the generator itself is putting out just 3-phase 460 volt, but then we're running 600 volt on the electric drive motor. So from the generator itself, it's a standard generator, 60 hertz. It then, through a rectifier and inverters, it then changes the AC to DC, puts it into the batteries, and then from the batteries, it goes back through the inverter into the electric motors, back as AC again.
Okay.
So basically, we just got to switch AC to DC for the batteries and then back again to the drive. And there is a little bit of voltage regulator in there that steps the voltage up. So if you're driving and you're using the electric motor, you can send the power directly from the generator to the electric motors first without having to travel through the batteries. And then the residual power that's not being used goes into the batteries for recharging.
Okay, that's great. We've got one company out here that is looking at this as a proposal. What they do is they do drain tiling for agricultural land, and super high horsepower, huge demand, but they're coming at it from a little bit of a different angle, is that they're having all kinds of hydrostatic drive issues with their tractors, especially as they get to, you know, 3,000, 4,000 hours and paying through the nose to have those fixed. What they're looking at this from is a reliability, an improvement in reliability. So any comments on what you've seen so far with what you've had up there?
Yeah, I mean, our trucks have only been on the road now for a year and a half, so we're still waiting to see that long-term reliability side. But for essentially looking at all the Laternals and electric motors have almost no parts to them. They're big stator, they're a magnet and some copper wire, some bearings that spin. There's not a lot that really wear out on them. You see electric motors that are over 100 years old. Like I say, that Laterno from 1967 is still out there unloading trucks today. Like that thing has like what, 200,000 hours on it. They're running 3 shifts, 5 days a week on these electric drive things, and they found that they were buying some normal diesel hydraulic equipment and replacing them every 5 years, 6 years. Okay, we need a whole new major rebuild. Whereas they kept looking at their old trucks, like there's these old log loaders from the 1960s. Talking with a mechanic there, they're like, "Oh yeah, they'll replace them when they wear out. They haven't worn out."
Mm-hmm. Well, that's good. Good. So let's open it up. Go ahead. Let's open it up to questions from you guys that are online here. If you've got a question, just put up your hand, turn on your camera, and yeah. There's Grant.
And Aaron.
Hey, Aaron. And Grant.
Hi, sorry, the audio, I was the phone call, but it was muted on me. So a question I had watching your videos, you talked about the challenges you had finding a manufacturer that could deal with the axles and the motor integration into the drive axles for the tonnage that you guys are putting on this truck. Could you talk a bit about that design process and how you found a vendor to help you with that?
Yeah, so originally, it's actually quite a funny story here that was the really thing that impacted us negatively at the start. So we reached out to Meridor because they were making those electric axles. On our first prototype, we ran with a drive shaft and a centrally mounted motor, and we were just blowing U-joints like crazy to the electric torque. We're like, we need electric axles, split the power in half, put it on each axle, get rid of the drive line. We reached out to Meridor for their e-axle, and they said, "Oh, that's awesome what you're doing. Can you promote us on social media?" And we're like, "Yeah, we're looking forward to working with the Meridor axle." We spent 4 months engineering around their axles, and then we went to go buy it, and Meridor told us, "No, you're not a big enough company. We're not going to sell you any axles. We don't want any small companies buying our axles." That's what they said in an email. So that kind of left us like, all of this, I'm sorry, my alarm keeps going off. We did all of this engineering around your axles. You won't do it. So what do? Some of the other companies were the same way. They said we were too small. So we worked with a company over in Europe and another manufacturer in China. Basically, we went to an axle manufacturer and said, "Okay, we got a standard axle. It's got your standard ring and pinion. Let's figure out a way to just attach an electric motor to that." So we came up with a little transfer case design, put the electric motor, and we just used the standard electric motor, connected that to a standard ring and pinion, sent the power out, and you end up looking at it. That's basically the same thing Meridor did. It worked out great though, because now we got the intellectual property on those axles, and it took a little bit. It was $500,000 in engineering to get that done, but now we actually have our own axle. And whereas the Meridor was only rated to, I think they're 35, 40,000 pound axles, we got a proper 52,000 pound actual axle that's spec'd for a logging truck. Like if you run a Meridor axle on your semi truck, you were only able to go to 82,000 pounds maximum gross vehicle weight, whereas our truck's gonna be rated for 300,000 pounds max gross vehicle weight with these axles. So it's going a little bit heavier, a little bit more skookum, and just, it was one of those things that we found again is that in the electric side, nobody was tackling the heavy duty truck market. So we kind of had to start from day one. But there is so many electric motors out there, so many different styles, kinds you can choose from. Like electric motors have been being mass produced for over 100 years. there was so many to choose from and so many companies out there that are experts in making that integration work, that it actually wasn't that bad of a process. If us Jippo loggers could do it, somebody else can probably do that. Has to.
So you've got the electric motor integrated right onto the axles on both drive axles.
Yep, and it packs power. So we've got 350 horsepower per axle for 700 horsepower in a tandem. And I can tell you that the amount of torque there is insane. It's 80,000 foot-pounds of torque to the wheels. And when we step on that throttle, you're just gone. Like I say, 100,000 pounds, and this truck does not even notice it's there. I was rolling, and I was doing about 10 kilometers an hour. You can see it in one of the videos, and I hit the throttle, and I just spin all 4 tires while fully loaded. Like, I've never been able to spin 4 tires in a truck like that while loaded, and that's kind of cool.
Well, and for you, that's 750 horsepower on the ground. That's not 750 engine horsepower minus fans, minus hydraulics, minus, right?
And it's a flat line torque immediately. It's just there. There's no RPM band. You just have flat, smooth. You got the whole power the whole way instantly at the ground. We overdid that. I'll be honest with you. It's so we spec that out to be 500 kilowatts, around that 700 horsepower. And when we first stepped on the throttle and drove it, we were watching our little computer, seeing what the data said, and it only took 40 kilowatts to actually move the load. Like, it needed 60 horsepower to actually get the load moving with the electric torque, and we put in 700. So we got 10 times the amount of power, and it's cool. It's awesome. Like, we let a few truck drivers come out and drive it, and their favorite thing, or my favorite thing that they said is, one guy said, "You asshole, you made me hate my truck now."
That's good. That's good. Any other questions, Aaron and Grant?
I guess another question about the tuning of the motor. And so was part of that axle development the software for the inverter so that you didn't start shearing teeth off the platter gear and stuff like that?
Yes. Yeah, that took a lot of time in the software end, is doing that throttle mapping, how it comes on there. Before we had the axle sent over, we had the axle sent off to a test facility, and they played around with a lot of how that torque was applied. And now we're still playing around with the torque because there's different things at different settings. Like, we've had to put in different drive modes. Like, I'm empty, bobtailed, I'm loaded, I'm off-road, has a different way of controlling things. And then we have the just fuck around mode. I want to be able to spin the tires. But basically, there's a lot of cool things we could do with that. But yes, that did take months of software work.
Mm-hmm. Yeah, I don't know if you're familiar with the Frontiers North Tundra buggies. They run buggies up at Churchill for polar bear tourism, and they've actually integrated motors onto their axles as well. And they spent an amazing amount of time in software development that they didn't understand had to happen when they first started the project. It basically delayed them a few months just to get the software done.
Yeah, they say that on the first one, the software takes as much work as actually building the thing. Mm-hmm. You can expect if you build something to do 6 months worth of software integration and testing, and to really fine tune and get that right. That is one of the biggest pains, is that, we spent like $40,000 having to get the software done on that truck.
Good stuff. Good stuff. Any other questions out there?
I've got a couple of questions on the axle. The axles that you're using, are they like standard differential or diff lock, or?
Yep.
And also, do the axles have integrated brakes, or how do you handle the braking requirement?
Yeah, so the axles are standard ring and pinion. The big difference is we went with straight cut gears because it's got regen braking to slow it down. So you're loading those diffs in the backward, like your ring and pinions will be loaded backwards with how hard that regen can slow the truck down. Straight cut's going to be better. And then for braking, it also just has your standard air brakes on each side.
Oh, okay.
So air brakes, that still all works the same. The axle itself, it's got full diff locks. Obviously, it doesn't have inner axle because each axle has its own electric motor. They're not connected. But yeah, it's the axle. Fundamentally, we didn't change anything on the axle other than the straight cut gears. The input shaft just comes from the motor attachment point, and other than that, it's this normal semi-truck thing, which is what I wanted, because I want to be able to refit an old truck, and if they've already got a good set of rear ends, I just want to be able to unbolt the front inner axle part off of the
Right.
rear end, electric motor, and bolt that on, send it out.
Sorry, I guess we'll just keep throwing questions at you until somebody gets in our way. Another thing that we found was really interesting in your design was the fact that you had the battery suspended for shock absorption. Was that something you learned a hard lesson, or was that just you figured that was the best way to deal with it right from the get-go and you always did it that way?
Yeah, we always did it that way. I mean, the first truck we didn't, but I thought of the idea after that. It wasn't going to do it an issue, but we were talking with our battery manufacturers, and they're like, yeah, just so you know, like a logging truck is going to bounce those batteries around and shake it. Like, that's not great for the lifespan of the batteries. You got to be able to find some way to cushion the blow on that. And we looked around and the cab runs on air ride, the suspension's on air ride. Why don't we just put the batteries on air ride? Like, it seemed like a no-brainer. And then it also eliminated, we were worried about frame twists because we wanted the batteries inside the frame rail so they were protected. Batteries are still an explosive thing. They're like a fuel tank. If you puncture them, if you hit them, and I was worried about, like, well, if somebody T-bones a semi-truck, they're going to hit the batteries, and it probably doesn't matter how much. Really, you can put a lot of metal around them to protect them, but why not put them inside the frame rail? If we got rid of the drive line, we can put them inside the frame rail, and if you have to go through a half-inch frame rail to then hit the batteries, you've probably got bigger issues at that point. So we were worried about frame twists because frame rails like to twist, and we said, well, if we put them on airbags, then those batteries can float independent of any frame twist. But what we found with the electric motors is that there was no frame twist at the end of the day anyways, but at least they're protected from bouncing.
Yeah, well, you probably when you're up in the logging roads, it's probably like the streets of Chicago. I had the chance to ride a bus in Chicago once, and oh my goodness, that was unbelievable what those buses go through. It's crazy. So, Thomas, you have a question?
Yeah, mine are all around batteries. So what type of batteries are you using? Are they power, energy cells?
Lithium iron. I know lithium iron doesn't give you the same density as lithium ion. It's a little bit heavier, but running as a hybrid application, it can take the charge cycles. It does thermal management a little bit better. So we don't need a lot of weight. Like, we really don't need a lot of batteries in our truck because we're going the hybrid route. So iron made more sense to us.
So to that end, what is the capacity of the battery pack?
So each battery module is about 35 kilowatts. They're just standard CATL batteries.
And how many strings do you have at 35 kilowatts per string?
There are 4 batteries to 8 batteries, depending on the application and how much power you're looking at. Is that some applications can get away with 3 batteries. We're speccing out 1, and 3 is all they need. One wants 4. Another one is going to require 8 batteries just because they're running a lot of other equipment off of those. It depends on the discharge rating of the batteries. The batteries are 4C rated, which means they can discharge 4 times their amount of power. So a 100 kilowatt hour battery can discharge 400 kilowatts worth of power. Is the easy math on that. It gets a little bit more complicated. I'm not the smart engineer from my team here, the truck guy, but the way that was explained to me is that, 100 kilowatt battery can discharge 400 kilowatts, which is about 500 horsepower. So each one is about 35. So if you want to put out 700 horsepower, 500 horsepower, you need at least 150 horsepower worth of batteries, or 150 kilowatt hours worth of batteries. So
yeah, and
kind of how
you mentioned your throughput of 2.5 to 3 megawatt hours per day, right?
that's right.
So I quickly go to the cycle life, and you're going to be running these logging trucks hard, right?
Yep.
So and with LFP, you've actually kind of got you got a longer life. inherently battery in that. So have you done predictions on battery life and replacement cycles?
Yeah, we talked to the battery manufacturer with them because they were really the experts in this. And we talked to some guys in a university in Toronto. They did it like a little bit of independent work on them. And it's not as bad as you think, because while the cycle life is a little bit higher, you're also keeping the batteries in their peak range. So we're keeping them between 40% to 80%. We don't go between range. So we're not doing full discharge cycles. And by also shunting the power back. So if you're operating the vehicle, the generator fires up, it's sending the power to there first. And they said the other nice thing too is that, yes, between 7 to 10 years, you're going to start losing your capacity. But as a hybrid truck, they said we shouldn't have to worry that much, because capacity is essentially smaller, means that you got a smaller battery. If you lose 50% capacity and you had a 100 kilowatt battery, now technically you kind of have a 50 kilowatt battery,
Right.
Which means if you're driving off the electric and then running the generator for half an hour or an hour if you're driving, instead you're going to be driving for 1 hour and running the generator for a half hour, 15 minutes. So it's a shorter charge cycle, and then it's going to get eventually to the point where your batteries degrade to the point where your generator is running almost all the time. But at least with the hybrid one, it's not as big a deal with that battery life cycle. So you'll find a lot of operators can push it, because a normal, if you were just a straight BEV, battery electric, if your batteries go down, it's going to be really annoying. If you had a run where, hey, I can do this run every single day, and then you find out 3-4 years later, whoa, I can't do the same run anymore. This truck is no longer able to haul the load I need to haul, or in your case, get the passengers, like it can no longer do the bus route, or we got to put in more and more charging and it has to stop for more frequent. That's going to be much more annoying than the hybrid, where it's just the generator running more.
Right.
So
And
that's my best.
yeah, in the end, you just see greater fuel consumption.
Yeah. And the batteries cost about $1,000. So the way we look at it is that in 10 years, you'll probably have to spend about 30 grand to replace the batteries. That's similar to basically doing an in-frame.
Okay. Very good. Thank you.
Good. Any other questions out there?
When you were talking about the battery, is it CATL was the vendor that you guys went with?
Yeah. I think that's the one we went with. I'm going to have to talk with my battery guy a little bit more. There was two, and we just made the choice on Topsy. There's a lot of good battery manufacturers out there, and luckily battery packs are starting to become standardized.
And you talked about 600 volts. Why did you go with that? Why did you choose that voltage?
No, that's definitely a question for Eric. I think we want to bump it up to 800 on the next trucks. Is that 600 was a little bit low. We should be around that 800, but essentially, because when we looked at the motor for the amount of power and torque and size requirement, there was a 600 volt motor, so we picked 600 volts because that's what the motor size was.
Okay. And sorry, I had just so many questions. When I look at the power distribution unit, I believe one of the videos you had it mounted behind the cab.
Yep.
Did you guys put that together, or did you have somebody out of house build that for you?
A little bit of both. We had a headache rack manufacturer build that. We had a guy put their couple pieces in, and then we did a lot of the work. So it was 3 people different worked on that.
Okay, so yeah, even down to some of the wiring, you guys took that challenge on yourselves.
Yep. I'll be honest, wiring is surprisingly easy on an electric vehicle. That's definitely something that we could have handled. It's 3 wires. You got and they say A, B, and C, and you put the A into the A and the B into the B and the C and the C. The electrical wiring I could do, and I am not an electrical engineer by any means. So the only thing is, it is an electric vehicle. That is one of the additional concerns, is that you have live voltage with the batteries. That's something I do caution everybody on, is that normally on a straight diesel mechanical one, there's nothing that can kill you. Like, that's my joking around. But what happened here? I totally lost my
You're
back.
back.
Okay, there's nothing on a normal vehicle that can kill you, but with electric is that you got to remember you have live power. It's like working in a piece of plant equipment. You need to be knowing lockout, tag out procedures. You want to disconnect those batteries, lock them out, and then verify that the power is actually locked out. Standard procedures to working in a sawmill or an industrial plant, but it's something that diesel mechanics will have to get used to. Any electrical engine, industrial electrician should be able to work on it, but that is an additional caution of these trucks. And that's one of those things that we sourced out for the headache rack, all of our safety gear and that power distribution thing behind the cab. That's the part that was sourced out. We did not skimp at all on the safety. That's the one thing we're like, okay, we need to have a company that knows this really well, do all the safety components, the ground fault monitoring system, the contactors, all of that. We'll get them to do it.
And so when it came to the commissioning of the whole system, when it was all said and done, did you have to bring somebody in to do that for you? To sign off on everything and do the EMI testing, that kind of stuff?
Yeah, the truck's actually in Ontario right now. It's going through that. We actually just got our approval that we can now issue our VIN number. So our first truck now finally has a VIN number. Now we're going to some more of the reliability testing, but yes, you do need a third party to certify that, have a look at it, and then give it an inspection and approval.
And so you had to ship it out to Ontario to find somebody that could do that for you, that size of machine?
Yeah. There were some more places around more locally, but Ontario had a lot of great testing facilities for above and beyond that, like for testing torque, power output, fuel consumption. They had a cold weather testing facility where they could bring it down to 40 below, 40 above, and test the battery heating discharge rates in that kind of in cooling, like what happens to the batteries when it gets cold. So Ontario had all of that, so we shipped it there. And then a lot of the other electrical parts we went with too, for in case you're wondering, we like Danfoss, used a lot of Danfoss ones.
Okay. So you did work with Danfoss quite a bit. And when it came to connecting the motor to the generator, like the diesel motor to the generator, that was fairly straightforward. That wasn't hard to make that work.
Well, did we lose Chase there? Oh, there he is.
Ask it again, maybe.
Yeah. Did you lose your audio there, Chase? Oh. Can you hear us, Chase? Yeah.
Hello?
There
Okay.
you are. Okay. Aaron, do you want to re-ask that question?
Yeah.
Apparently the way things work is that I have to actually phone my audio into the meeting. They can't record it through the phone. And if I get a phone call, apparently it kicks me out of the that call.
Shoot.
Maybe it's somebody
Sorry.
ordering a truck.
And yeah, a guy wants he wants a tow plow. He makes tow plows. So actually kind of one of the cool ones we're doing. We've sold all of our trucks for production for next year, and we're tackling a couple cool ones. One of them is a snow plow. We've got a hydrovac unit. We got a drilling rig, like a little service rig that's going to be done on that, and then a mine truck, logger truck. So it's kind of a cool little application.
So how do you get introduced to these people? Or they just have seen you on Globe and Mail and on YouTube and hey, can you help us?
Yeah, that's basically it. They've either seen us on the article on the Globe and Mail, different news article, or they've just been watching our YouTubes. And most of it, they find that, yeah, they see an article or they hear something, and then they go and watch the YouTube, and they're like, oh, I should probably reach out to these hillbillies and see what they can do. And it's it's kind of our goal with this whole electric thing, is to make people see that electric doesn't need to be complicated. And that's working out really good for us, is that where a lot of companies like to hide everything they're doing and all their parts things, and then they find out, like I've heard from other companies where they've talked to people about their electric vehicles, and a lot of their mechanics have questions and they have no answers. Like the salesmen have no answers on how it works or how it does anything. It's a big mystery. And because we show everything, they feel actually pretty comfortable coming in with us. It's that, or it's a double-edged sword. Some people look at us and say, whoa, you guys are a bunch of hillbillies working out of a tent, which is true. And then a lot of people say, whoa, I really like what you're doing and how you're showing how all of this works. Let's give it a try. So it's
Interesting. So anybody else out there have questions? No, seeing none. If Bueller's got more questions, keep going.
Sorry, I guess I spent a lot of time thinking about this topic. So, and I will admit your get her done attitude definitely caught our eye too. So we're one of the fans, I would say, of what you've done. When it comes to some of those other projects, it sounds like you might be getting yourself into some EPTO type applications where you're trying to supply power to other units like hydraulics or vac drives, stuff like that. Is that true, or are you just relying on the rest of the truck components that would normally have been there to do that type of work?
No, we built an EPTO, so to run different kind of hydraulic attachments or hydraulic equipment, and which was actually really hard to build. We had to take an electric motor and attach it to a hydraulic pump. No, EPTOs are pretty simple. We just took literally an EPTO. You just grab an electric motor, you stick it to a hydraulic pump, you run some power lines to it, and you put a little switch to turn it on and off.
So yeah, you found that was a fairly simple process to meet the needs of what you're trying to like imitate or like recreate on the truck.
Oh yeah, I mean, you look at farmers. Farmers have had EPTOs. I get so tired of electric companies. They're like, look at our new EPTO. We have a groundbreaking Every farmer I know has some form of EPTO, as they put an electric motor on a hydraulic pump to run some piece of equipment that they built in their backyard. Like, it's nothing new. No, the EPTO is one of the things is figuring out the size, the electric motor size you need for the hydraulic pump. But what we do is we just look at this thing and say, what size hydraulic pumper, what kind of horsepower hydraulic pump are you running right now? Oh, we're running a 40 horsepower. Perfect. We'll stick a 40 horsepower electric motor on there. Done. That's about as simple as we got in our engineering. But there's people getting a little bit fancier, and they can go off the deep end, and then for having the power come on and off on demand and different little things like that. And I'm a big fan of keep it simple.
And so obviously this is something that some of your customers are used to, electrification, but some it's very foreign. Good old diesel heads, they haven't had to deal with much more than 12 volts. Are guys scared of this? Like, do guys actually push back against you, or is it seeing is believing, and once they touch that throttle, you have a customer?
Yeah, it's everybody that we've ever brought out to that's driven the truck has said, holy crap, this is the future. Now, I don't know, there could be selection bias, the people that want to come out and see our truck, and we offer test drives to the people that come and see it. They just may already be naturally curious, so there may be a selection bias, but everyone we meet and show this truck off to loves it. Even some of the people that came out very skeptical, but it's, when we start making sense, a lot of people don't like it at first. They don't like electrification because they don't like the way electrification is being done. They feel like it's being rammed down their throats, that they're not going to be able to work on these things, repair them, that it's going to be super expensive. And we've just been kind of trying to dispel some of those rumors about it. And like, a lot of it, what I find is there's a lot of media or something where it says, if you don't like electric, then you're dumb, or you know, this is the way of the future. Everything's going to be rosy with electric, and you get guys that they don't like electric because they're actually kind of smart. They know how much power their truck requires. They know how far batteries can go, and they're saying. So when we put in the diesel generator and explain that hey, this works a lot similar to a freight train from the 30s, they kind of come around. They're like, oh, I wasn't against electric. I was against the way electric was being ran down our throats. So.
Thank
Good.
you.
So,
That being said, there's a lot of people that are, you know, they're skeptical. They want to see the truck do some more working. How's that truck going to be in 5-10 years? What's the long-term reliability? And that's fair. We got to still prove that.
so with the truck that you've been running, what's the most unexpected positive that you've seen so far out of it? Something you didn't even think about as you were designing it?
Oh, unexpected positive. Honestly, the acceleration, like I knew it was going to be good and I knew it was going to be powerful, but I did not expect it to be that. Like when we were saying like 600 horsepower, I think we forgot a lot about that. That's power that takes the engine fan off, that transmission, rolling reduction, and then the flatline torque curve. Like I didn't realize how powerful that actually was going to be. And one of the things that we thought was actually going to be nice turned into almost like a net negative. I thought is going to be quiet. When it runs on battery and the generator's not running, it's totally quiet. And I thought that was going to be nice. But holy cow, you hear every noise and creak and groan in the truck. You can hear your different turning. Any cab squeak, like anytime anything squeaks in the cab, it drives you nuts.
Mm-hmm.
We actually had to we built our cab, we had to redesign and build a whole cab around the whole ethos that nothing can rattle at all in this truck. Like we bolted things on there with like grade 8 bolts instead of just using like plastic things to like push it in or quick screws. Like we used grade 8 bolts with nylocks and we physically bolted everything to the dash so that it couldn't rattle because it's too quiet. It is oddly too quiet.
And my car, they actually play exhaust notes through the stereo. So it, well, in my case, it's to make the little 6-cylinder engine sound like a V8, but you definitely don't hear the squeaks or rattles.
Yeah, that's something we're kind of looking at is like, hey, maybe there should be some kind of noise on this to cover some of the things. Because like nobody wants to hear their differentials and like there's sounds that when I first drove the truck, because of course we built it, we're nervous. We're like, whoa, what's that noise? What's that little ping? What's that little, and you find out that they're normal truck noises, but just your diesel motor was covering it before. And some of these applications are going to be terrifying. Like talking about with one company about doing up a winch tractor for them. I can only imagine when you're loading with that winch line with no engine sound, no revving, you're going to hear every little ping and fray in that winch line. Like that, you can normally hear that over a diesel engine revving. That's probably going to be terrifying for the operator.
Yeah. Well, good stuff. Good stuff. So any other questions out there? Oh, here comes Gordon. Gordon, Fort Garry Fire Trucks, Canada's largest fire truck manufacturer located in Winnipeg.
I apologize, I was a bit late. When I first saw your technology, I thought, well, that will work well for us too. Now, do you have any plans of creating some kind of modular package that you can sell to different industries, like in different sizes, let's say 350, 500, 700 horsepower?
Yeah, we're working on that right now, and we're planning to put it together as a kit that we can just basically sell the kit, and then people can install that on their own. And yet we are playing around with some of the different horsepower, some of the different specs. tandem, single drive, battery sizes, and it basically is going to require, you know, sitting down with an engineer. What do you need? We'll sell you the parts for those kits. Here's how it works.
Aaron, does this qualify for next round of financing from VTC?
If it's your first foray into diesel electric hybrid, I would say, yeah.
Okay, then we'll talk, I guess.
Yeah, we did find that the guys that we were partnering with are getting shred credits for it too, because they're spending a lot of money on engineering for things like service rigs and all that, things that have never really been electric or diesel electric, and it's a first time integration. So they are getting a lot of shred credits as they go down this road. So that's always a nice thing too.
Good. So Chase, if people wanted to get a hold of you to have a conversation specific to their sector or type of equipment, or, you know, I'm interested in learning more, what's the best way to get a hold of you?
My email, chase@edisonmotors.ca. It's always a fantastic way to get a hold of me if you're interested in going down a project or a few more questions. Right now, though, we do have all of our build schedules, like everything is kind of full up until now, till 2025, so we can't build any more trucks. But if you've got some questions about yours, you guys, I'd be happy to answer some more questions.
Okay. Any other questions out there?
There's one from our team that came through the chat. Sorry, my lead electrical engineer's on the call too. He was wondering who you use for your ground fault monitoring check. Like, yeah, who did you use for ground fault monitoring in terms of a vendor? Do you know?
We went with Flowdraulic, Danfoss, Edison. Those guys have they're really getting heavy into the electrification of equipment. They've got a lot of experience in electrification, and I gotta say, like Danfoss and Edison through Flowdraulic has been absolutely fantastic with us on this project for that. They've got some really, really bright people on there. I could not recommend them highly enough for what we've done. If you're thinking about doing something like that with them, yeah, you're making the right choice with that company.
Yeah, and here in Winnipeg, I think it's Berenson Fluid Power is the Danfoss guys that we work through in our manufacturing, and that I've traveled down to some of their research facilities, actually in Ames, to see their electrification research down at their application center there. So if you want to go, it's an amazing tour.
Yeah, they're supposed to bring me down here in January to go check it out there for all of the electric things they're doing.
Yeah, no, they're great down there. I would highly suggest it.
Well, I'll check it out.
Good. Any last questions?
When's your next YouTube video coming out?
Should be pretty quick here. Yeah.
Yeah, and we're going to post this conversation on our YouTube channel as well for those that couldn't be a part of the meeting. I wanted to keep the group small, just because it's easier logistic wise to do something like this rather than with 50 people. So this will be on YouTube as well.
Perfect. And the next YouTube, we've just designed our pickup truck kit, so we're going to be unveiling that as kind of the next big YouTube thing. Here. We took the same technique from the semi truck, and you were asking Gordon about scaling. That's exactly what we did. Is that we used a lot of the same parts for our semi truck. So the semi truck, for example, has 5 inverters. The pickup truck's just going to have 2 inverters. Instead of having 6 batteries, we need 3 batteries. So we've been able to reduce it, but we were able to keep all the same batteries, inverters, contactors, and all that. And we've scaled it down into a pickup truck kit. And now hopefully people will just be able to buy kits, take one of the kits, put it in their pickup truck, and then head off if they want to do the same thing to like a service truck or a welding truck, or just even an old classic pickup truck that they want to have more power out of. So that'll be the next big thing that we're working on now that we've sold all of our semi truck spots.
Mm-hmm. So what the future of Edison Motors? What if I were to get a hold of you in 5 years, where do you think Edison Motors is going to be?
You know, I just want to be a supplier of really good, reliable electric truck parts. And I want to build trucks. We've got enough, like, I just want to build heavy vocational trucks and supply good, reliable kits for pickup trucks for people that actually use and work these things. So we're hoping we're going to grow. We're hoping that we're raising a little bit of money here, building a little factory to put these things out. And hopefully in 5 years, we're looking at a serious factory to actually really start manufacturing.
Good stuff.
The demand is there. Just got to figure out how to build it.
Yeah, well, hey, being sold out for a year is not a bad thing.
No, not at all.
Oh, good stuff.
And we had up truck reservations, and we had a little reservation sign-up list. There's 13,000 trucks on that reservation list. So now we got to figure out how to actually meet that demand.
Well, that's great. Great problem to have.
It is, but it's like this whole thing went way above and beyond where we expected to be when we started it.
Yeah.
Like, we were just a bunch of log truck drivers. We thought we'd build a cool truck. It'd be a cool series. We could show people how it worked, and we would eventually move up. And we thought, well, it's going to take us 5-6 years to build the first real prototype. Like Tesla takes 6-7 years. And then we found out that we've already built 2 trucks in 1 year, and now with the truck's got already approval and it's VIN number and can go driving, and we can actually sell them. Like, the whole thing has happened way faster. So I can't even predict where we're going to be in 5 years.
Oh, good stuff. Good stuff. So, hey, on behalf of our group out here in Manitoba, we thank you for your time today and for sharing information about your technology and your company, and encourage any of the companies that are interested in learning more to reach out directly to you. And yeah, let's hopefully there's some conversations come together in the future.
Yeah, absolutely. And like, if anyone else is thinking about doing some electrification, they've got a cool little project that they've asked some advice on, feel free to reach out.
Awesome.
Thanks for having me, listening to me talk, I guess. Share this.
All right. Well, thanks so much for your time. We really do appreciate it. And we'll be in contact in the future.
Awesome. Take it easy, guys.
Thanks, Chase.
Thank you.
Thanks so much, Chase.
Bye.